In this video, we are going to run and interpret a Cox regression model for analyzing survival data. We shall first give the general interpretation, then we go a little bit into the details of interpreting hazard ratios and coefficients. Consider watching our previous episodes to appreciate how to run the different steps 1 up to 5. In this episode, we assume we've gone through all steps 1 and 5, and then we are just interpreting the results of our final model. If you find these videos useful, consider liking and subscribing to the channel for more of our content. Here is our hypothetical survival time data that we are going to use to run and interpret the results of our Cox regression. We have a variable for ID of the participant. We have the event variable, whether the event happened or not. In our case, the event is death. 1 for the person died, or 0 for did not. And then time to that event happening. Then we have 3 independent variables that we want to use to predict survival time. So to run our Cox regression model, we have to first declare our data as survival data in Stata. First, go to Statistics, Survival Analysis, Setup and Utilities, then declare your data to be survival data. Mine is already declared, but in this time variable, you put the variable that shows time to event. Then under failure variable, you put that variable having the event happening or not happening, and then you specify what code specifies the event happening. In our case, a death is coded as 1. Then we click OK, and you will see the survival time data settings. Their details are put here. To run our Cox regression model, simply go to Statistics, Survival Analysis, and then Regression Models. Go to Cox Proportional Hazards Model. Then here we are going to specify our independent variables. So we have gender, treatment, and age. Since gender and treatment are categorical, I can use I dot before the variable name to tell Stata that these are actually categorical variables, so it will create damage for them. And then under reporting, I want you to appreciate that by default, we shall get hazard ratios, but there is an option of reporting coefficients, not hazard ratios. So I'm going to leave it at reporting hazard ratios for now. I'll click Submit. Here is our output of the Cox regression analysis. We have number of subjects. Our sample size is 287. Then those where the event happened, they are 163. And the total time at risk for all the 287 was this value here. We also have the likelihood ratio chi-square test, and it is overall p-value. A significant p-value shows us that by adding our variables into the model, we have significantly improved its prediction power. As opposed to other regression models where we have the value of the constant or the intercept, this one here we do not have that value because this is a non-parametric model, where others refer to it as a semi-parametric model. The baseline hazard is undefined. So in the table, we have our survival time here, and then the independent variables. We have the hazard ratios, their standard errors, the z values, and the p-values. We also have the 95% confidence intervals for the hazard ratios. Generally speaking, a hazard ratio of 1 shows no difference in the hazard. The two groups that you're comparing have equal risk at any time. But if the hazard ratio is above 1, that shows a higher hazard in the numerator group compared to the reference group, or increased risk. When we look at our output, we see that males have a hazard ratio of 1.02. So this shows that males have a hazard that is 2% higher than female. And if the hazard ratio is less than 1, that means a lower hazard in the numerator group, or that group compared to the reference group, or a protective function. And we can see that from our output for treatment B. When you compare participants in treatment B to those in treatment A, we have a hazard ratio less than 1. So that shows us that subjects receiving treatment B have a hazard that is 58% lower than those receiving treatment A. To get this protective function, it is not as direct as this. It is a matter of getting 1 minus this value. It gives you the magnitude of the protective percentage. So that's the general interpretation when you have hazard ratios. Remember when I was telling you that under reporting, you can also choose to report coefficients. If I click coefficients and then submit, so first you will appreciate that the p-values we obtained are still the same. Like the one when you are reporting coefficients, here we have coefficients, the p-values are the same. For a model reporting coefficients, the general interpretation of the coefficients is quite similar to that of hazard ratios. Here, instead of a no difference being indicated by 1, the no difference is being indicated by a 0. And if your beta value is above 0, then it shows higher hazard or increased risk. And if it is less than 0, then it shows a lower hazard of that group compared to that reference group. So next, let us look at the interpretation of the actual values in the regression output besides using these general interpretations. We shall start with the interpretation of hazard ratio. If we are having our model that is giving us hazard ratios like the one up here, this value, yes, we've said that above 1 is showing higher risk. In mathematical terms, the hazard ratio you're seeing that corresponds to the males, the one of 1.02 something. That hazard ratio is the log of the hazard ratio for an individual in one category, the males, compared to another category, the females, while other variables are held constant. And when there is no time dependence, remember we are dealing with Cox regression, where the assumption has been fulfilled and there is no interaction. If it is a continuous predictor, like this value for age 1.019 something, that value is the log of hazard ratio for a unit change in the levels of the predictor, in this case age, while other variables are held constant and there is no time dependence and also no interaction. Next, we see how to mathematically interpret the model's reporting coefficients. What do these coefficients stand for? So a coefficient for a categorical variable like male, this 0.24 something, that beta or that coefficient is the difference in the natural log of hazard for an individual in one category of the predictor, that is gender, the males compared to females, while other variables are held constant and when there is no time dependence or no interaction. What I want you to appreciate here is that when we are talking about betas, it is a difference in the natural log of hazard. But when we were talking about hazard ratios, it is the log of hazard ratio, not the difference in the log of the hazard ratio. Because mathematically, if we are talking about betas as a difference in the natural log of a hazard, so if you have log A minus log B is the same as log A over log B, which is a hazard ratio. So the word difference automatically is dropped. So the rest of the interpretation remains the same, except that part of a difference. When we are talking of betas, it is a difference in the natural log of hazard. But for a hazard ratio, it is a log of hazard ratio. So for a continuous, it is the difference in natural log of hazard. For a unit, difference in the levels of predictor variable, while other variables are held constant, no time dependence, interaction. If you found this video useful, consider liking and subscribing to the channel so that you don't miss out any of our episodes. So this is the last video in a series of episodes that we've been making about Cox regression. So next we are going to look at extended Cox regression, which is the right model to use if there is violation of the pH assumption. It allows you to accommodate the time varying covariates. See you in the next episode.